So we're going to start with this section 2.4 on one-sided limits, dealing with those concepts about the existence of a limit existing on one side and not the other, or that they are going in opposite directions. So what we're doing is reviewing a few things about domain. In this function, what is a domain for f of x equals 9 minus 6 divided by x squared? What do we know? What is the domain? Well, we understand that in this case, we know that x cannot equal what? 0, because we did the divisibility rules in our first encounter with this chapter, because then it is undefined. And this is not an open hole. This is an absolute asymptote. It does not exist. In fact, they're both going to infinity. Okay, because it's a square. So, in this case, we know that we would write it as an interval as negative infinity is to 0, union with 0 is to positive infinity. And for simple terms, we just know it can't equal 0. Well, then I gave you this one, this example here. And in this example, we're talking what happens with this. First off, what is it? What kind of function do I have? Square root. And what is the square root? What is the restrictions with a square root? Can't be negative in the radicand, right? The inside cannot be negative because then it'd be imaginary. Excellent, thank you. And so what we do is we set the radicand greater than or equal to 0, because we can take the square root of 0 and then do the math on it. So I'm going to have a negative x is greater than or equal to a negative 2. I'm going to divide by a negative 1. What happens to my inequality? It flips. That's right, switches. So this means x is all values less than or equal to 2. So the interval would be the negative infinity, comma, negative 2 bracket, because it is inclusive of that value. Everybody okay? Everybody remember that? Okay, and we could graph it and look at it in that fashion. So we're going to consider limits in this section as we did before, and going on either the right side or the left side. Yes.
Would that be a positive?
I'm sorry?
Wouldn't that be a positive too?
It was a positive 2. Thank you so much. I appreciate that, because my notes would have been all catty-wonka. The two-sided limit approach is another way of proving that the limits on both sides are going to the right number. It is used as a proof, and it's used in engineering to make sure we can apply something. Green's theorem or some other engineer's theorems that give us that flux capabilities. But in any case, it is part of the big scheme of limit. Even though we know the precise definition of a limit with the epsilon and delta, this one says, let's go from both and see if they exist. All right. So, notations. We're saying the limit as x, because it's always about the domain, approaches some constant, some c from the left. That negative is not an inverse sign. There's no 1 there. It is a minus. And this is from the left. We'll have the next consideration, we'll have the limit as x approaches c from the positive, and that means we're approaching c from the right. So much. All right. In your careers, there are many capabilities to override an exception. And here is one. Is everybody comfortable with that? All right. So what does it say? And this is the elegant definition. Suppose that a function f is defined on an open interval. That means that it is not inclusive. It can be, but it's not inclusive by definition. Containing c, except perhaps at c itself. Again, always that exclusionary concept. Then f of x has a limit as x approaches c. Now here it is. If and only if. IFF, if and only if, one-way conditional. Both a limit from the left at C and the limit from the right at C, and those one-sided limits are equal. So that says now we're getting fine-tuning. We're going from both sides and seeing that the limit exists. But again, you can use it on one side more than the other. All right. So let's view this guy right here. Use the graph below to determine whether the statements about the function y equals f of x are true or false. First, what do we have? What kind of function? We have a parabola. More explicitly, we have a piecewise function, right? Mm-hmm. Because the f of 0 is the value 4. And then, because it's open there, and then f of 3 is actually 0. Does everybody see it? All right. So we're looking at these things and saying, all right, what's going on with this function? What is going on? All right. True or false? The limit as x approaches -3 from the positive side. So here is -3, and we're approaching it from this side. Okay. All right. We're going here. Is that right? Only from the right. F of x equals 9. True or false? Thank you. Absolutely. It's a closed dot. Does it exist coming from the left? No, it doesn't. There's no function. The interval that the whole function is for this guy is -3 to 6. So we can't start on the left side. It doesn't exist. There is no function to measure. You need at least some portion of a function to draw your connection with. Very tricky, right? True or false? The limit as x approaches 0 from the left, okay, left is this side, is 4. The limit is false. Why is it false?
Because
0. So well said. The value of f of 0 is that 4. but it's not the limit. Breathing? All right. All right. True or false? The limit as x approaches 0 from the left and 0 from the right are equal. True. Therefore, the limit as x approaches 0 is 0. Because the left and the right are going in the same position. Remember, so close it can touch it.
Yeah, they're just basically.
Yes. Right. True or false? Oh, and I forgot to say, oh no, that's correct. The limit as x approaches 0 is 0. And this is true. True or false? The limit as x approaches 3 is 9. It's a positive 3. All right. And it didn't say what side. So what happens here? Well, it's approaching from the left to what? 9. But from the right, it approaches 0. So it's false. Is that okay? Everybody good? Okay. True or false? The limit as x approaches 6 from the left is 6. What is the outcome? It 0. So this is, we can do it from the left, we just can't do it from the right. So the limit does not exist for x equals 6. Everybody good? They both have to be the same. All right. Piecewise is the hardest, I know. I'm so sorry. You have to think very hard. I don't like thinking very hard. Okay. So we have a line for x is less than 3. And at 3, it is 3. And at 2x divided by 3 for any value greater than 3. So we have a good function, a very good function. Find the limit as x approaches 3 from the positive side. So where is it going? Where's it approaching? Find the limit from the left to 3. Also 2. Find f of 3. 3. It didn't say limit. It says what is the worth? All right. Does the limit x approaches 3 of f of x exist? The answer is yes. I couldn't get this going. Sorry about that. Because the left and the right are going in the same position, reaching the same general vicinity, then therefore it is. Even though f of 3 is 3. Okay. Okay. So this guy right here, we have an upside down parabola. Okay. And we have it at, if it's 0, it's 9. And it doesn't exist at -3. Okay, at -3, it is 0, isn't it? Correct? It is 9. Okay. At 0, it's that. And then at -3, which is right here, it would have been 0. Okay. Then it's 7 at -3. Okay. Find the limit of f of x as it approaches from the left and to the right. Does it approach anything on the left? Well, yes, it does, because it keeps on going, doesn't it? It doesn't, there's no, only its restriction is that. So we have this. All right. So if I'm going from the left, it is what? 0. If I'm going to the right, it is 0. Yes?
Yeah, I see it.
Does it exist? Yes. It didn't say it's at -3 on the upside down parabola.
Right.
I know, trick question. Okay. Another piecewise. I know. Aren't these lovely? Oh, I'm sorry. You were working. Sorry. The only restriction we had was that it couldn't be -3. Any questions? I'm sorry. I don't even ask. We have to be aware. Right? Okay. All right. Can I move? No, not yet. No hurries. Now, I gave you paper on how to graph that in the grapher. Put them in parentheses, the parameter. Here we go. Are we good? Yes? All right. Graph this function. What is the domain and range of f? Oh my goodness. All righty. Let me try to sketch that. From 0 to 6. I don't have any, oh, okay. And we're talking, oh, okay. If it is 0, it is 6. Nothing is negative. All right. Okay. If I have this guy right here, at 0, it is 6. If I go to 6, it is 0. All right. Then from 6 to 12, it is 6. 12 is an open hole, isn't it? Because it doesn't equal 12. At 12, it is 12. That's what I have. Does everybody agree? Did I do good? Check me out, because I could make a mistake. So, what is my domain? It's in close bracket, bracket 0 to 12 bracket. Correct? I've accounted for everything.
Yes.
All right. What is the range? Ooh, okay. From 0 to 6. Union with 12. Okay. Is that okay? Or plus 12? I don't know. I think union with 12. All right. At what point C, if any, does the limit of f of x exist for x equals c? This is A. My B is the limit as x approaches c of f of x. All right. Okay. We don't have anything on this side. So it would be at any value from here to here. And it's an interval. And any value of 6, not including 6, 6 to 12, not including 12. Anywhere else, it's not going to, okay, because we have a what? A gap here and a gap here. But anything in between will work. And a gap here. Is that pretty good? All right. At what point does the left-hand limit exist but not the right hand? Okay. The left hand is the limit as x approaches, and it would be this guy right here, 6 from the left. Okay? Because the right does not exist. Does that make sense? From the left, we would have this guy here. And then we would also have the limit as x approaches what? 12, right? From the left. All right. And that's all we have. Oh, right? I'm doing it right.
No, I mean, just whoever invented this stuff kind of invented it back. You think going to the right is positive, going to
Now, here's the other aspect. When does the right-hand limit exist, but not the left? And that would be, again, at 6.
yeah.
And then also 2, as it approaches 0 from the right.
Yeah.
Breathing?
Mm-hmm.
Everybody okay? Okay. That's that one. All right, now we get to our first rule. Our first derivative rule. There is, and it'd be really interesting if you do look up the YouTube on it. There's a proof in the book and a proof on YouTube that sine of theta divided by theta is, as it approaches 0, is 1. Okay, and it's a very, very intense little proof, but it's a lot of fun. And it goes like this for this. And then you have to keep on widening your graph and widening so that you can see that it's approaching 1. Does it get there? No, because you can't. You'll have undefined. But everything else is going to be the sine curve. Is everybody comfortable with that? Okay. All right. So this is to memory forever and ever and ever. That if we have the sine of an angle divided by that angle value, which is in radians, that means it's a number, then it's 1. Or if I have the radian measure divided by sine of theta. So we're going to be manipulating to get what we need to get that to happen. Either by identity, by manipulation, by multiplying by 1, making equivalent fractions. All kinds of ways. Is everybody comfortable with that? Okay. Memory forever. All right. And again, the limit of sine theta divided by theta as we approach 0, as theta approaches 0, that means a radian measure is 0, is 1. All right then. So we have this. We have the limit as theta approaches 0 of 8 sine square root of 2 theta divided by the square root of 2 theta. Well, we know this is our identity. So the limit is 8. Right. Any questions there? Ta-da! Obvious, right? All right, then not so obvious. In this case, we have a k as a constant. The limit as t approaches 0 of sine kt over t. Now, in this case, sine is a multiple, so it is only moving faster, or more condensed, if you will. So, what do we have? Well, we have 0 over 0, and therefore it is 1. K is of no importance.
Correct. Neither close.
Okay, trick question. A lot of trick. All right. This guy. Well, we have this condition, but we only have the y. So we're going to multiply the top and the bottom by 5. All right. So now I can say this guy is 1. Everybody see it?
Mm-hmm.
Questions? Cheesy easy.
You can also see it in the original equation. It's right there in front of you.
Yes, you can. All right, here we go. Now here is an identity. So cosecant is 1 over sine, right? So I'm going to have x over sine 4x times 1 over cosine 3x. And now I'm going to multiply this guy by what? 4 over 4. So now I'm going to take the limit as x approaches 0 of, okay, now this is 1, correct?
Yes.
I'm sorry, I include the 4. 1/4 times 1 over 1. Now, this one is just an algebra consideration. We need it. We understand that we've got 2 theta and square root of 3 cosine theta. And we need angles that make, right? And we need a plus and a minus, or a minus and a plus to get 0 to occur. Does everybody see that? All right. So if I've got a square root of 3, then I need a small angle, like a pi 6, because that's a half.
Yeah.
I mean, the square root of 3 over 3. Actually, I need pi thirds, don't I? Pi thirds. Okay, and then I could have going to be 1 less, so that would be 4 pi thirds. This is a plus and a minus, right?
Yes.
And this is a negative. This is a positive. And then I have this guy over here. This is 1, 4. This is 6. This is 7. I'm thinking these work. Maybe it's pi 6 I need, really. I think I need pi 6. Sorry about that. The square root of 3 over 2. Nope, I need the pi thirds. Sorry about that. Had to think. All right. So, okay. So now I'll know what I need. In this case, if I do 2 times this guy, it's not going to work. It's going to be this guy and that guy. This is going to be negative 1/2 and the negative square root of 3 over 2. If I double this, I end up here.
The protector went down.
Why?
Turned off.
It's not good. Oh, there it is. Okay. So if I double this angle, it puts me over here for the sine, and that'll give me a positive. And cosine will stay negative, and that'll be the square root of 3 over 2. So this one works.
Messed up.
Acting wacko. Okay. So if I have the sine of 2 times 7 pi thirds, 6 and 1 more pi thirds, then I'm going to have, because that would make it, no, sorry, nobody caught me on this. This is a 5. This is the 7. Because it's, no, why do I have this wrong? Oh, this is a 2, and this is a 4, and this is the 5, because I'm thinking 6s. Sorry about that. Okay, if I double this guy, I'm going to get negative. Oh, positive, negative. Yeah. So I can use this one or this one, I think. Let's try it. Let's try it. 2 times, and I'm thinking this guy will work because it's positive, negative. And if I go 2, it's negative, positive. Yep. I think that one will work. 2 pi thirds plus square root of 3 cosine of 2 pi thirds. Okay, well, this guy's negative. And this is 4 pi thirds, which makes it negative. Doesn't work, right? Because that's 4. Didn't work. That one's not. So it's got to be this one. Sine of 2 times 4 pi thirds plus square root of 3 cosine of 4 pi thirds. This guy is negative. And this guy is 8, which is right here. It's positive. And that is 0. So that's one of them. I thought this one would work. Sine of 2 times pi thirds plus square root of 3 of pi thirds of cosine. Sorry. Oh. Just wrote this one wrong. Cosine of pi thirds. Okay. This is going to be the square root of 3 over 2, because it's a half times the square root of 3. And this guy is, no, they're both positive, because it's 2, it's right here. So, no, just this one. That's the angle. And that's it. I am done. You'd have to try all of them and figure out which one's going to be positive and negative, because it's doubled. Maybe this one would work too. Maybe that one. Anyway, you'd have to try them out, because that'll put it over here. And that one is positive, and that one's still positive. Nope. It's only the one. All right, guys. Thank you very much for listening.